Alright class, this is number 94. We have an initial velocity and we have a range that we want to get to. So the one thing I noticed right away is that this is in feet per second and this is in yards, so we want to change them to all the same units. So either you could divide this or multiply this by 3 or divide this by 3. Either way will work. So we want to figure out when we get to 1,000 yards, so I'm going to put 1,000 yards divided by 3, now it's feet, and I'm going to substitute that in for r. Initial velocity of 1,200 feet per second, sine of 2 theta. So all we have in this equation is one unknown. The best way to do this problem is to graph it. I would subtract this from both sides, and then I would put it as y equals 1/32, 1,200 squared, sine 2 theta, minus 1,000 over 3. The toughest thing for this problem is to get the graph to show up on your screen. Okay, so I challenge you to try and do it on your own. Try see if you can figure out where this function crosses the x-axis with a reasonable value, because it's going to cross it a number of times since it's a sine wave. It's going to cross it a number of times, and you have to figure out which of these is reasonable. Okay, so I challenge you to pause the video and give it a try. Alright, so here is how I would do this problem. Okay, if you graph it out, it would look something like this, where this it's crossing a number of times, but the only one that's going to make sense is this first time right here, and it's going to be a really small angle, because if you think about it, between 0 and 90 degrees we're going to shoot this gun, right? Now, does it make sense to shoot at a target over here and have an angle bigger than 90 degrees? No, that doesn't make sense. You're shooting behind you. Okay, does it even make sense to shoot a rifle with an angle bigger than 45 degrees? Not in this application. I mean, you could think of like a tank shooting at more than, or a missile launcher or something going at more than 45 degrees, but just a rifle, it's going to have a real low trajectory. You're going to be aiming basically right at the target. So if we zoom in here, we're aiming right at the target. This angle is going to be really small. Okay, so that's one key to your window. In fact, when I started this problem, I thought, well, I know my x value is going to be probably less than 10 degrees. Okay, and we can even shorten that up further. Now, this is 1,000 yards, or in this case 300 feet. So we know that's how high we're going to go at least, that's the midpoint. So we're going to start at 0, and then we're going to cross this line, and then it's going to come back down at some point, well off of this screen. I probably shouldn't have had that, probably more like that. So 0, this line is about 333, and then it's going to go further, and then it's going to come back down at some point. So we got to find this angle. So you could have your window start at, actually this would be the 0 line here. So you could have your window start at like negative, I don't know, 10 to positive 10. What's my window? Maybe let's make it easy for you. X equals my X min 1.5, X max 2.2, my Y min negative 1,000, my Y max is 2,500. This gives me a real nice way to solve this problem. But maybe try and understand why these values work, and that'll help you understand why we get that answer.